So Francesca Rossi has, and you can see on the bio that she shared with all of us, has a very, a deep experience in AI. So she has been like a researcher in the field of AI for an eternity. And she also has played, she has played a lot of important roles in the AI community, like chairing IJCAI, which is the International Joint Conference on AI, a very important conference on AI, and basically also being part of AAAI, another an association for the advancement of AI. So she's this very strong presence in the AI world. And more recently, and while she was a professor at Padova, the University of Padova, and more recently, she actually joined IBM. And at IBM, she has been leading the efforts on understanding this problem of AI and ethics. Along these same lines, Francesca is also the part of the founding members of an institution called Partnership on AI that combines Google and IBM and Microsoft and Facebook and all these big tech companies towards having AI be used for the good of society. So in some sense, you are going to listen to a person that I've known for many years, and that will bring to us the experience of knowing about the research and also the community and these new goals of trying to make AI and ethics together. Francesca has many papers published, She has many honors. She just published a book in Italian, I understand, about actually like getting to people to know what AI is all about, the general public. And so there are many things that you can find more about Francesca. Also, about like 5 years ago, 6 years ago, we were both here in New York, or I was in New York, and Francesca was also, I guess, already at IBM? No. You were still in Padova, and I was here on sabbatical, and we had actually what we call the New York AI Summit, and we put together like 40 or some people on AI to discuss a lot of issues. So she's an excellent speaker. She has a lot of experience, so let's please welcome Francesca Rossi and thank her for being here with us.
Thank you. And I hope jpmorgan will join the partnership on AI. Hi, good morning. Thanks, Manuela, for inviting me here. I'm happy to speak to all of you. If you have any question, you can stop me at any time or wait until the end, whatever you like. So today I'm going to talk about issues around AI. So AI has, as you know, many capabilities, but it also has many limitations as a scientific discipline. And also brings certain concerns and risks. Some of them are legitimate. Some are less, in my view, legitimate, but they get a lot of space in the media. So that's also why I published this book for non-experts, because as you know, the non-experts, they don't know anything, and they just read about these very extreme views about AI on the media, like AI is the most terrible things that can happen, or is the most, it can solve all the problems of the world. So that's the extreme views that they get. So instead, it's very important that everybody understand the real capabilities, limitations, and risks and concerns about this technology. So today, I'm going to talk a little bit about this, very little about capabilities and limitations, because I'm sure you know about them, but also about the concerns and risks, and also what the community and people are doing in various ways to address these concerns. So this is just a very, very brief one-slide history of AI. Just to make sure that you understand my point of view on AI, which is beyond machine learning and beyond deep learning, of course. AI started in the 50s. The term AI has been used for the first time in 1956. over time, of course, in the first few decades, the most successful way of developing AI and deploying it were, algorithms that were telling machines how to solve problems, but without the machine having to come up with these algorithms. And then in the 80s already, there started to be another approach, which is the machine learning approach, which is based on data, where, you tell a machine how to solve a problem by giving examples. Is oversimplifying thing, by giving examples. So you're not telling exactly, the steps to solve a problem. And these algorithms were already there in the 80s. Then they evolved, they improved, and recently, the deep learning approach. And I'm just writing that and singling it out. But there are, of course, many other machine learning approaches, but the deep learning one is the one that is most visible and popular and successful in many applications. But, to give you the idea that for me, and also coming mostly from the kind of reasoning kind of artificial intelligence, so for me, there are these, and I will tell you a little bit more about, there are these two approaches to AI that more and more there is evidence that need to be combined in order to really overcome the limitations. So, of course, as I said, these machine learning approaches were already there, not as improved as now, but were already there in the 80s, but of course they did not work well because we did not have enough data to train these algorithms, enough examples, to make this algorithm learn how to solve a problem. And even if we had enough data, which we didn't have, we wouldn't have had enough computing power to just look and handle this data. So the coexistence now of a lot of data, a lot of computing power, and improved algorithms allows, these machine learning approaches to be very, very successful. And the reason why we have now the data is that we produce the data. We produce a lot of data, all the videos that we put on YouTube, all the likes, all the pictures, all the things that we share. And we didn't have ways to share them with everybody until recently. And so with this coexistence of these capabilities, then these algorithms are very successful. For example, here there is this ImageNet classification error, so to classify correctly what is in an image, and this is on a data set that has been used for several years as a benchmark to test these algorithms. And already in 2015, it was, less, it had an error rate which was less than that of a human being. So as I said before, so there are these two main paradigms, which if you think about it, they're very obvious. How do you teach somebody to solve a problem? You teach it either in two ways. If you know the recipe, the steps to solve the problem, but you write down this recipe and you code it into a system, and then the system from now on knows how to solve the problem. And this approach, called the reasoning logical approach, works well in those problems that are very clear and where the researcher knows exactly that by following these steps, for sure you find the solution or you find the optimal solution and so on. For example, in your whatever Google Maps or navigator that you use, the algorithm is just that kind of algorithm. It's a kind of reasoning logic algorithm. It's an algorithm called A* that is in every textbook of AI, and it's just a sequence of steps. And if the machine follows those steps, for sure it will tell you, it will obtain the optimal solution, like from the optimal route to go from where you are to where you want to go. So, and the reason why you can do that and it works well is because there is no vagueness. The input data is where you are, where you want to go, the maps, okay? And this is abstracted as a graph. which abstracts all the things but they're not relevant to the solution of the problem. And then, on this abstraction, you can use this algorithm to find the best route. Then, of course, you can say this is a very simplified way of doing it, solving the problem, because of course you can take into account the real-time, traffic, whatever. So many other things where you can insert data. But the basic approach is a typical approach where the reasoning methodology for AI works well. Instead, there are other situations, other problems where you cannot use this approach. Of course, you can use it, but it doesn't work well. And for example, image classification, image interpretation is one of them. So if you want to build a system that recognizes whether in an image there is a face of a person, how are you going to write the steps such that if you follow those steps, for sure you have the right, correct answer? That the way the face can be in an image is so varied and so unexpected that you are not able to do that. And covering all the possible cases. So in that case, you say, okay, I cannot tell you the recipe, but I'll give you a lot of examples. I'll give you a lot of pictures, and I'll tell you for each one of these pictures if it is the image of a person or not. And then you give an algorithm to the machine that allows the machine to learn from these examples and to extrapolate and generalize in a way that it behaves well also on pictures that has never seen in the example. So those are very obvious ways, if you think about it, of telling somebody, whether it's a person or a machine, how to solve a problem. And as you know, the kind of AI that we have right now and we had so far is the narrow kind of AI. So AI that can solve a specific problem very well, even maybe better than a human being, but it's not the kind of AI that can go from one problem to another one, learning here and using what it learned over there and so on. So this approach is typical for, these two approaches are for generating the narrow and vertical kind of AI. So that's why more and more people think that if you want to make AI a little bit broader and make it learn from horizontally from one problem to another one, probably what you need is a combination of these two approaches. Okay, this is another more visual thing, way of looking at the fact that AI as many sub-disciplines as a scientific discipline. So as I said, there is machine learning, and inside machine learning there is supervised, unsupervised, deep learning, reinforcement learning, so many variants. There is symbolic reasoning and knowledge representation, planning, scheduling, so a lot of sub-disciplines. All of this is part of computer science. And then, of course, there is robotics, which in the media, of course, is the usual, representation of AI. But robotics, of course, in some sense, it's true that to make a robot behave, in a way that it can achieve the goal that you've given the robot, you need to embed into the robot AI algorithms and methods. But of course, robotics has to do with many other disciplines as well that have to do with the physical part of the robot, so engineering, control, and so on. So it also goes outside of AI for all that for all those issues. So AI, given all these capabilities that we of solving problems, as you know, it is in many different applications in our everyday life. And here I just put pictures of some of them. But of course, it's not just providing services to individuals like social media, like checking credit card, but it also helping many companies in improving their operations or in creating new way of doing things inside the companies, making it more effective, less costly, but also, really changing the way companies operate. And given, however, all these capabilities and all these services that are given to us by AI, but of course AI also has a lot of limitations. In fact, if you look at it from the application side, it looks very successful, very advanced technology, and it is in terms of applications. But if you look at it from the discipline, scientific discipline point of view, in some sense AI is still very primitive. For example, especially in the machine learning area, it's very a primitive way that machines learn how to solve a problem from data, because what the machine learn is just they learn an input-output relationship. They learn that given this picture, they have to say yes or no to whatever you ask about the picture. And they learn very well with a very low error rate and so on, but they don't really understand what they're doing, and they cannot do any other task and any other, they cannot respond to any other question on those pictures, on those pieces of text, or on those videos and so on. So, and the reason why AI cannot do that is that it lacks a fundamental reasoning capability that we have, which is common sense reasoning. So common sense reasoning is something that we use so much whenever we do things and whenever we interact with each other, and AI, still we haven't understood how to embed that into an AI system. And again, combining learning and reasoning is something that still is starting right now in the recent years, but for the most part of the history of AI, these two approaches were kind of parallel and not really talking to each other. The third thing I call natural language understanding. So, of course, AI can interpret natural language, like Google Translate can translate with almost, very high quality, very few errors, but it's not that it's understanding that language. Or Alexa can respond to our questions, our phone can respond to our vocal commands correctly, but there is no real understanding of natural language. And this is the reason why you don't see any dialogue system. You only see a lot of question answering system. But then the next question, yes, go ahead.
A little more, what is understanding? What would a system which...
Okay, I'll give you an example of lack of understanding, so maybe we can... So basically, if you understand a piece of text, for example, of course you can translate it well, if you know the other language, of course, but you could also, you should also be able, if you understood that piece of text, you should also be able to answer other questions that I have about that text. While Google Translate is very good at translating, but doesn't have any clue of what that text says here in this language or in the other language and so on. So, yeah. Yeah.
If I gave you a system that could do what you just said, then you would come back and say, but it can't do this other thing.
It could be, and there is always this Chinese room argument, maybe machines don't need to understand in the way we feel we understand data, or we understand text or images and so on. Maybe there is a different way, which is mostly the input-output things that you observe of the machine. But still, there is a lot of limitation in interpreting natural language that is, and the current state is very good for very specific tasks. But again, is not horizontal. The machine can handle text, but it cannot really. It doesn't know how to extract information from a piece of text, for example, that then it can reuse also for other tasks. So more and more broad. Of course, there is no threshold. They say, okay, now it understands, and before it was not understanding. So as you say, it's a moving post, and it's broader and broader.
As far as answering the questions about text, I think as far as answering questions about text, I think that given Google's speed, I think we're, if we're not there yet, we're pretty much there. But even when that happens, I won't really feel like the computer understands. And so I just kind of want to...
It could be, but now we are at a very primitive stage, I think. A very primitive stage, in my view. In really, being able to handle natural language. And again, the proof is that you cannot have a dialogue with the machine. And I'll give you an example of this lack of, ability to resolve simple things that we resolve when interpreting natural language. And of course, also learning from few examples. Machine learning needs a lot of examples, usually supervised machine learning. And there are situations in which you don't have a lot of examples. Like think about a new problem in a company. It's a new problem. You don't have a lot of examples. So you need to learn how to solve that problem by learning some very general concepts or coding and mixing coding and learning some very general concepts and properties. And then the machine should use all this information, the domain knowledge, the knowledge of the expert in that field and some data to be able to solve the problem well. So how do you learn from few examples? And then, of course, is of robustness. Robustness means that, yes, the machine learning approaches have very low error rate, sometimes even lower than human beings, but they can be fooled in ways that are very, shocking to us. And I'll show you some example of that. So how do we cope with that situation? Okay. Yeah, so here is a small example about what I mean that it lacks natural language understanding. So there is this challenge, a Winograd schema challenge is called, that requires a machine to solve a very simple anaphora resolution, which for us human beings is very, very simple. So all the challenge is like being able to resolve and to understand what a pronoun refers to in sentences that have all the same schema, and the schema is what you see here in this example. So the box for example, the box did not fit in the suitcase because it was too small or too large. Okay. Now, what does that it refer to? Of course, if you write small, you know that it refers to the suitcase, and if you write large, you know that it refers to the box. Okay, simple enough for a resolution. For us, it's very, very simple to solve it. The best teams from all over the world, the best universities, the accuracy is 60%. Almost like flipping a coin. Okay, so it tells you that if machines cannot resolve that pronoun anaphora thing, how can they have a dialogue with us? Because we have a lot of these things when talking to a machine. So this is just one small way of understanding that still machines are really very primitive in being able to interpret language. Okay, so there are, besides the capabilities and the limitations, there are also some risks. And this comes, the whole area of AI ethics. So AI ethics is an area that only very recently, came about because of the pervasive applications of AI into our society in many ways at scale. So people started thinking, okay, but since this technology is so impactful in our life, let's think about, how is it going to change the way we live, the way we interact, the way we work, and so on. So, and whether the decisions making by this technology, decisions or recommendations to a human being to make a decision, whether these decisions really do have the properties and the values that I would like to see, and I expect from a human being. Now that I give the decision to a machine, should I expect the same properties or even more or less or whatever? So the AI ethics area has really been picked up by many areas and many groups of people in academia, in companies, in other institutions, in the policymakers, governments, and so on. Like in Europe, for example, every one of the European countries has a national AI strategy. In Dubai, there is a minister for AI. So even policymakers are really starting to think about this. So, and here you see just how much it grows over the years very recently. So this is one slide where I just wrote what are the main concerns, okay, about that one could include within AI ethics. So the first group of concerns is about the properties that you desire of the technology once it is deployed in some application. So the first one is bias. So you would like your machines, once they're deployed, to make decisions possibly or recommend human beings to make decisions. And while doing that, you would like the property of fairness. Whatever that means in that specific context, we know that there are many, many different definitions of fairness, but once you identify the correct one, and possibly together with those that are going to be impacted by the decision and so on, you would like the machine to make decisions following this property of fairness, right? So it means that you should try to detect if the machine has some bias and mitigate it, okay? And of course, if you use a logical reasoning approach to AI, in some sense, you are coding and you are telling the machine exactly what to do. So it's explicit if you are coding some unfair way of making decisions. But if you are telling the machine how to solve a problem indirectly with examples, with data, then this indirect way of telling the machines what to do can, you could inject bias into the machines by choosing the training data sets or by any other decisions that you make in the design or the development of the machine, because you're really not directly telling the machine what to do. So it's easier to inject bias if you're not careful. But it's not just fairness. Fairness is just one of the properties that you would like the machine to have once it is deployed. There are many other values or guidelines or code of conduct or other properties that you would like the machine to have. So in general, people talk about value alignment, meaning that once it is deployed, the machine makes decisions or gives recommendations. I want these values to be followed, to be aware, the machine to be aware of them and to be followed. One of them is fairness, but there are also other ones. Just, for example, any business conduct guidelines that you expect from a human being in a certain profession to follow. So if you give this human being a decision support system, of course, that decision support system should be aware and should be able to follow those same business conduct guidelines, just to give you an example. The third one is the issue of the black box. So these machines may have all the values that you want, all the fairness properties that you want, but if you cannot be convinced of what values they are following or why they are making certain recommendations or certain decisions, then probably you're not going to use them in the long run. Especially if they recommend you decisions that are not just like recommending the next book to buy, which, okay, if you make a mistake, it doesn't really matter. I don't need to know the motivation why you're recommending me this book. But if you want to make decisions that have to do with giving somebody a loan or not, or, giving some social benefits to somebody or not, or using a certain therapy for a patient or not, then, of course, for this decision that are very high stake, you probably want to have some motivation and some explanation of why certain decisions are suggested by the user. So the machine cannot be a black box. And of course, this is an obvious observation. Yeah, of course, like human beings, you should explain, and also machines. But unfortunately, machine learning methods are kind of opaque in this respect. And so there is a lot of effort in the research community to try to embed explanation capabilities into machine learning approaches. Okay, so these are some properties of the technology. Then, of course, there is the issue of data. So since machine learning is so fundamentally based on the availability of data, then questions arise about what happens to my data. So I am happy to give my data to a machine that gives me a service, because I understand that if I give my personal data, the machine will give me a more personalized service, which is better for me, and not just a service which is the same for everybody, so maybe it's not exactly tailored to me. But on the other hand, I start asking the question, what happens to my data once I release them? Who is going to own that data? Who is going to pass it to? What are they going to do with the data? Just giving me the personalized servers that I expect, or are they going to use it in some other way to manipulate my preferences or other things? So the issue of data are very important, especially in some parts of the world, and so much, for example, that in Europe there is already a regulation, the General Data Protection Regulation, that I mean, it has to be questioned, the effectiveness of that regulation, but is a regulation that wants to, all over Europe, wants to give some rights to the data subject, which is us, the people that give in the data. The next one is accountability. So we know that some of these statistically based, machine learning based approaches have always a small percentage of error, and this is intrinsic in the fact that they are statistically based. But so then we put them together in the loop with a person to mitigate this error and so on, but still there could be some incorrect decisions. So when the incorrect decisions are impacting people in a negative way, are harming people, who should I ask for, I don't know, compensation or for redress or for something? So especially, I don't know, in the judicial system or in the healthcare system or even the financial system. So the whole area of accountability and responsibility has been, and also from the legal point of view, has been built around people making decisions and not about machines or machines plus people, whatever. So there is a lot of discussion of how should it be changed in order to account for the fact that some of these decisions are made by machines or teams of machines and human beings. The next bunch of concerns is about the impact on society. So the first one is the impact on jobs. Okay, are some jobs going to disappear because they're jobs that can be automated and can be done by AI methods? And even if a job is not going to disappear, but probably in every job, some tasks are going to be automated completely, and the other tasks, maybe they're not going to automate it, they're going to remain to the human being, but the human being, probably in those tasks, has to work together with the machine. So it has to be retrained, it has to learn how to interpret what comes out of the machine to make his own decisions, and so on. So in general, every job will be transformed. So how do we cope with this transformation? How do we help people to cope with this transformation? When there was the Industrial Revolution, things were happening because there were physical objects that were built in the factories. Things were happening with a certain time, a certain scale of time. And so we had the time, the society had the time to put together educational initiative for everybody so that everybody could take part of this operation. Now things are happening very fast. So how do we retrain and help everybody being part of this transformation and take advantage of it? And of course there is the impact on society, meaning how we live, how we interact with each other, how we interact with machines, what happens with our children that grow up with thinking that Alexa is like their friend, preferring to talk to the Alexa or with Siri than the other kids and so on, or even, the interaction, the addiction to the social media. So how is that the transformation of our life that we really want in the long term or not? And then there is this issue of the deep fake, so AI now is very good not only at interpreting images, videos and text, but also at generating new content, new images, new videos and text in a way that is practically indistinguishable from a real meaning generated by a human being or by a camera, whatever, in the case of an image. So if we cannot distinguish what is a real image, like a real face or a real person or who talks with which voice and whatever, if we cannot distinguish what is real and what is not real, many of our systems on which society is really based on, like, for example, the legal system, have to be rethought, because even now, probably, or in few years, we will not be able to use an image as a proof that something really happened, or a video as a proof that something really happened. So how are we going to deal with that in a legal system? Just to give you an example of something that is so fundamental to give rules for a collective society to work well, if we cannot really distinguish what is real and what is not real. The next one is about the uses of this technology. Often people say that AI is a dual use technology. In fact, AI has the same technology, the same algorithm has many different possible uses. So it has to be a very conscious decisions about which uses we want to have. We cannot just say, okay, this is the technology, it's a neutral technology, now people can do good and bad things, like a hammer that you can use for good things or for bad things. We have to be more conscious about what are the possible uses, but also what are the desirable uses and the non-acceptable uses of the technology. So, and I think about, autonomous weapons, or I think about large at-scale surveillance systems of society and so on. And then there are these long-term concerns about the singularity and the superintelligence, which have to do with the concern that as machines become more and more capable of solving problems, and even more in an horizontal way, like in a broader way than the narrow way that they have now, then are we sure that we can stay in control of these machines? And if we lose control of these machines because they are become so capable of finding resources by themselves, solving problems and so on, how can we make sure that then we are not left as a marginal species if you're not in control of what they're doing? And of course, this has to do also with the issue that I mentioned at the beginning of value alignment. The more machines become capable, the more there is the need to make sure that they are aligned to our values, because otherwise they can do very damaging things if they are not aligned to our values. So let me give you, so here I just say that many of these concerns and these initiatives to solve these concerns and to address them are around this notion of trust. So how can we build this technology and use it in a way that we can build a system of trust for the technology? So there comes the properties that we want to assure in the technology, but also trust towards the people that are building and delivering the technology, and also trust towards the people that are going to regulate and to give rules to use this technology. So the issue of trust seems very central to many of these initiatives. So at IBM, for example, we focused on this, at IBM Research, but then also in the business units, we focus on this idea of trust a lot, and we say, well, what does it take to trust the decision made by a machine, besides the fact that we want a very low error rate, right? Yeah. But besides that, what do we need? Well, we need that is fair, aligned to our values, as we said, that is easy to understand why it makes a certain decision, that is robust, and that is accountable, meaning that it's transparent, the capabilities and limitations. So that's why we have these 4 pillars around this vision for trusted AI. So I'll just give you an example of bias and how it can be easily injected even without wanting into a machine. So bias, of course, is a prejudice, no, in a human being. In prejudice that can lead us to make decisions that are not fair. And of course, the reason why AI can be biased is because we design the AI systems. And since human beings, like you see here, have many different kinds of biases for human beings, of course, it is very easy for us to not even in an intended way, but to inject some of these biases into the design and the development of the machine. Here is give just an example of how the bias in the training data gets inherited by the decisions of the machines. So here I took just Google Translate. I took 2 sentences in English. He's a nurse, she's a doctor. I got that translated into Turkish because by doing that, the machine lost the gender information because Turkish doesn't have the gender. You see, there is just a big O for he or she. It doesn't have the he or the she. So then, at that point, I asked the machine to translate it back to a language, any language in English, that wants the gender. So in that second step of translation, the machine had to guess the gender because he had lost it. Okay. And where does the machine goes to guess the gender? Well, it goes into well, it extrapolates and generalizes from the training data sets. So if the training data set has that most nurses are women and most doctors are men, of course the machine will say, well, to be as correct, to minimize my error, I better say that the nurse is a woman and the doctor is a man. So this means that, of course, this is not a high-stake decisions, just, okay, made a mistake in translating, but you can imagine, so in general, in high-stake decision scenarios, so what we put in the training data set can get, inherited by the decision making of the machine. So, for example, if you train a machine that has to decide whether a loan request is accepted or not, and you put together a lot of data, meaning loan request, and then yes or no, whether it should be accepted or not. And if you're not careful about this data that you are collecting, and for example, all the loan requests that you say should be accepted, by chance, because of the data that you collected, they all come from women. And all the ones that you say it should be rejected, they all come from men. Well, the machine will get that correlation between the gender of the person and whether it should be accepted or not. You didn't see it probably. You just said, okay, these are all the data I have for examples of loans requests that should be accepted or not. But the machine will pick up that correlation and then it will use it probably when making its own decisions. So now the question is, but of course human beings are biased. So now if we replace or we help human beings with machines and make machines were biased, but is it better or is it worse? Well, human beings, yes, they are biased. We have a lot of bias, as I showed you before. But of course, it's easier to detect and mitigate bias in a machine because you can analyze the training data sets, for example, or you can do some tests on the machines. It's more difficult to detect it in them and to mitigate it and to correct it in the mind of a person. So in some sense, it's better that the machine is biased rather than human being. On the other hand, a human being that is biased is one human being. It's making a lot of decisions, but it's just one human being. It doesn't replicate automatically to many others. While the machine, if it is biased, then everybody can buy that same machine. So then every loan, request, systems are going to be biased. So there is this issue of scale, of course. Okay, value alignment. As I told you, value alignment has to do with the fact that you want the machine to solve a specific problem, but at the same time, you wanted to do it while following some guidelines and some code of conduct. Here is like a funny list of examples of value misalignment. They are mostly on the online game domain, and they show that even if the developer didn't want the machines to do certain things, but using a machine learning approach, it just told the machine what to do by giving examples and so on, and other machine learning approaches. But if you do that, of course, the good thing is that the machine has some freedom, some space for creativity to solve the problem in a way that maybe is even something that we could not come up with. But on the other hand, the machine can also do things that you do not expect in a negative way. So, for example, here you see an Eurisco game-playing agent that, of course, was supposed to learn to play well the game and therefore to go very high in the list of names and scores, like you have when you play a game, and instead just hacked that list. So he didn't learn to play the game at all. He just hacked that list because he understood that that was the final goal. And of course, that's not what the programmer, the developer wanted. Or another one, a sorting program that was sorting a list of numbers that was always outputting the empty list, because by definition, the empty list is always sorted. Or a game-playing agent that was killing itself at the end of level 1 to avoid losing at level 2, because of course he knew that losing at level 2 or higher level would have a very negative reward signal or score. And many others. So there is a very much longer list at that URL. But so to tell you that sometimes, this seems like, okay, how come we behave like that, but of course, those programmers did not think that the machine could do something like that. They thought about, they thought that they had given the machine the information to solve a specific problem without doing this and this other thing. So it's important to be able to understand how to bound the freedom of the machine, not completely, because you want the machine to be free to find good solutions, but to bound it in a way that does not do an undesired things. So that's the value alignment issue, the value alignment task. Okay, explainability, as I said, is another important thing. No, so if you don't have explanations, probably you won't trust the decision of the machine. And explainability, as compared to bias and fairness, as one additional complication, that of course the explanation has to be understood by whoever receives that explanation. So for the same decision, you may want to produce several different explanations. Like in the healthcare system, you want to use, when you have a decision support system that recommends a certain therapy, you want to give a certain explanation to the doctor using a terminology technical that the doctor understands, technical in the sense of healthcare terminology that the doctor understands. You want to give a different explanation to the patient, a different explanation to the developer that may use that explanation as a debugging tool. Okay, to understand why the machine has made that decision. And you also may want, in, again, very high-stake domains like healthcare, judicial system, and so on, you may also want to need to give an explanation to the, whoever is going to judge that decision, if somebody is asking for a redress. So, to the regulatory body that is looking on those decisions. So, explainability has this additional problem and issue of really having to be tailored to the recipient of the explanation. And of course, there are many, many approaches to explainability, but still, I think we are very at the beginning of this. So robustness, as I said, it's easy. So machines are very small, that are deployed, a very small error rate, but they can be fooled easily. What does it mean, easily? Fooled easily in the sense that, let's pick images in image interpretation. Even images that differ just for a few pixels, one from the other one, which to us, human beings, they appear exactly the same. Okay? Machine can interpret them in very different ways. So, for example, the ones on top, only there are images of 4 images of an ostrich. Only the one on the left is the original one and is correctly identified as an ostrich. The other ones, they look the same to us, but actually they differ for a few pixels here and there, and they are interpreted incorrectly by the machine. One is a safe, one is a shoe shop, one is a vacuum, whatever. The second, I mean, that is kind of a funny one, but the second, the lower part of the slide shows you something that is more concerning, because the image, like the box called with the A, that's the original image, so a street with some pedestrian and so on. And the one to the right, the prediction, the B, is the correct interpretation. So the machine correctly identifies some pedestrians and the street and the buildings and so on. But then the one below A, so the C, the adversarial example, is the same as the image, original image, but with few pixels changed. And now, to us, it's exactly the same. You will still see the pedestrians, we still see the street, but the machine does not see the pedestrians anymore. Right? So you see that, you can imagine that this is a very area where people are very concerned. For example, in this case, for self-driving cars, but also in many other situations. And it's not yet clear how to solve this problem. Okay. So even though machines may have like only 3% of error rate, But these errors are very strange because they make errors in things that to us they're very easy, and so it's not easy to understand. So far, we didn't understand. The research community didn't understand how to solve this problem well. The last issue is about this transparency, meaning, okay, so suppose that I take care of explainability, I take care of robustness, I take care of fairness and value alignment, but then I deploy this system with all these properties, and then how do I make sure that it's used in the most appropriate way, and that whoever is using it or deploying it, if it's a company, it can understand what are the real capabilities, limitations, and risks of this piece of AI. So it's very important to be transparent about these three things: the capabilities, the limitations, and the risks. And the idea that we came up with at IBM, but there are many other similar ideas in other companies, is we call it the fact sheet. So it's a list of questions that during design and development, they need to be answered about all the design choices that have been made. What kind of bias did you detect? What kind of mitigation algorithms for bias did you use? What kind of databases did you use to test that? What form of explainability did you inject? And so on. All the different, and also what kind of error landscape that machine has. Does it have a lot of false positives or a lot of false negatives? Because of course, this makes a difference when you want to understand what's the appropriate or non-appropriate uses of an AI system. For example, if you have a face recognition system with a lot of false positives, okay, it's okay to use it if you're looking for a missing child, because the worst that can happen is that you stop more children than you should have stopped. But it's not okay to use it to incriminate people, of course. So you see that the same piece of AI with the same capabilities and limitations and the error rate, it can be very appropriate to use it in a certain context, but not in another context. So it's very important to have this transparency, not in the sense of releasing the data sets and the algorithm, things that are almost always proprietary, but instead in the terms of documenting the design choices that allow whoever is going to be on the receiving side of this AI system to understand the capabilities, the limitations, and the risks. There are many things that are done in research, technological solutions to address bias, explainability, security, robustness, and so on. But there are also many other tools that people use, like best practices, guidelines, certificates, standards, auditing systems, and so on, and even laws and regulations. And there are a lot of enablers, like education, educating students, educating developers, educating the policymakers. And also dissemination, and also governance. What is the right governance approach for a country that wants to be able to use AI in its, for example, public sector, and what is the right internal governance for a company? What are the relevant issues? What are the relevant AI ethics issues for a specific company? And how can that company address those AI ethics issues within the company? What are the pieces that he has to put in place? An AI ethics board, maybe, or maybe a protocol, so that the business units can tell the board when what they are doing, what they are trying to deploy, and whether to understand whether that's risky or not in terms of the ethics issues. How can research innovations, like the technological solutions, be injected easily into the business units? How can we make sure that the business units, once a company has the right, for example, bias detection algorithm, how can we make sure that the business units use it? How can they have the right incentives to spend time in doing these things rather than just deploying it as fast as possible? All these approaches, all these initiatives, it's important to understand, if it goes back, well, it doesn't matter, that they are all multidisciplinary. So the AI people alone or technological people alone cannot even identify the issues by themselves. So you need sociologists, you need philosophers, you need psychologists, you need people that are expert in from outside, looking at the technology and understanding what's the impact on society, to be able to raise issues. And then the AI people can find possibly the technological solution, but you need to be able to engage with all these experts in other disciplines as well as the policy makers. Education, of course, is very important. Here is just a very initial part of a very long list of courses that there are in academia. This is a crowdsourced list of AI ethics and computer science ethics courses all over the world, mostly in the US, but also in other parts. Everybody can add new courses if they know about another course, but it's very, very long. Several weeks ago, when I took this screenshot, it had more than 200 entries, so probably now it has many more, but so you see that more and more academia feels that there is the need to educate AI and technological people, engineers, to know how to advance the capabilities of AI, but at the same time be aware of these issues around AI ethics. Okay, at IBM and in many other companies, we do a lot of things that try to address these many concerns. The ones at the top, you see this AI Fairness 360, Adversarial Robustness tool, AI Explainability. So there are 3 open source toolkits that everybody can use to add code, data sets, algorithms, tutorials, demos around these 3 fundamental issues around the properties of the technology. One of them is fairness, one of them is robustness, and one of them is explainability. And the idea is to help the research community to get together into an open source place where everybody can share knowledge and results about how to address that issue and to better understand it. But then also we have, for example, the blue one in the middle is called Everyday Ethics for AI, which is a booklet that we have built and we have written for our developers, but it's available for everybody, to really remember in their everyday job all these main issues, all this possibility of unconsciously injecting bias, and all to remember to try to inject explainability wherever they can, and so on. So really something to get our developers aware of the issues, and then the AI fact sheet that I already mentioned. But there are also many other initiatives that we are involved externally that in a very multidisciplinary way, and each one with its own specificity, try to address these issues. Somebody building certificates, somebody building guidelines, somebody building list of principles. So, for example, here in the top left, there are the Asilomar AI principles by the Future of Life Institute. Those were were written in 2017 by a very multidisciplinary group of people that started with more than 100 principles for the beneficial use of AI, and then they voted the principles, and those 23 were the ones that unanimously people in that group decided. And for example, those are very high level principles. They're not very specific and concrete, but they have been picked up. For example, the state of California has adopted formally these principles over the state of California as principles that every AI system should follow. The one in the middle, the IEEE, is a book, a very big book that tries to help developers, the engineers. IEEE is the Worldwide Association of Engineers. So it tries to help engineers to know more about the issues and how to solve. So possible recommendation on how to solve the AI at these issues. The one in the top right is what Manuela mentioned, the Partnership on AI that was funded in 2017 by 6 companies, IBM, Facebook, Apple, Google, Amazon, and Microsoft, okay, 6 companies, in 2017, with the idea to have a shared place and common place to share best practices, to define best practices about the beneficial deployment and use of AI. So we were 6 companies in 2017, and now we are more than 100 partners, of which less than half are companies, and the rest are everybody else, basically, UN agencies, academia, advocacy groups, ACLU, and others, and so on. Yes, you had the question.
Yeah, you answered part of it, though. So the 6 funding companies, they're all American, and my question was how much of this consensus building is international?
Yeah, so...
China.
Yes, so there are more, we expanded to companies, as I said, we are about 100 partners, and the companies are much more than 6, they are almost half of the 100, and there are companies also in Europe, in Asia, like, for example, there is Baidu, there is Sony, and then several other ones in Europe, but the idea, the intention is to have a very wide coverage geographically, but also coverage in terms of the roles of the company. So those that deliver AI, those that use AI, and those that are impacted by the AI solution. So all the sectors, so in the automotive, the healthcare, so we still are expanding to reach this coverage in these various dimensions, but one of them is, of course, the geographical regions. Then the one at the bottom, these 2 ones with the circle there, are the 2 deliverables, two reports of the it's called the high-level expert group on AI that the European Commission put together. This is an independent group of people that the European Commission nominated, 52 people, very multi-stakeholder, multidisciplinary. I think that in 52 people, the AI experts are definitely less than 10, okay? And then there is everybody else, consumer, rights advocates, lawyers, sociologists, philosophers, academia and companies, business people, and so on. So those 2 reports are the blue one is the ethical guidelines for AI in Europe. And there we start from human rights, we go to principles, and then we go to 7 requirements that we think AI in Europe should have. And we call it trustworthy AI. So again, the notion of trust comes again. And these 7 requirements are similar to the things that I told you. It has to be the data issue treated in the right way, the fairness, the explainability, the accountability, and so on, and many others. And then the green one is later on, we published also the green one, and it says, well, okay, now that we know that we want to have trustworthy AI, now these are the recommendations that we give to the European Commission to make sure that it gives the right incentives and policies to support trustworthy AI in Europe. So the idea is that to help policymakers understand how they can facilitate the development of that kind of AI in that part of the world. And although that thing is in that part of the world, so not here, not in China, no? But I think that there are several elements and also in the content of the document that could be useful also in other parts of the world. Another thing that I wanted to mention is the one at the bottom left, which is a new conference that we started like two years ago. It's called AI, Ethics and Society, because scientific conferences also are very siloed, very monodisciplinary. So there are conferences on AI, of course, there are conferences on ethics, there are conferences on other things, but there was not one conference that could put together experts of the various disciplines, talking to each other, learning from each other, submitting papers that are evaluated as usual in computer science, and a subset of them accepted and then presented and then exchange opinion and so on. So that one is being supported by AAAI, which is the Worldwide AI Association, and ACM, which is the Worldwide Computer Science Association, and to really fill that gap and have a multidisciplinary AI ethics conference. Those are additional slides that I want to show, so I will stop here and wait for questions if you have.
Let's
yes.
First go right on. Thank you.
Yeah.
Hi, is it working? Okay. So I
I'm thinking back at the beginning of the talk about the main concern slide that summarizes a bit all the risks. So I think there was bias, and I think all of the concerns, and in fact your whole talk applies to biological intelligence, to human biases, and you mentioned it at some point. Humans are biased because of education, lack of data, undersampling of trauma.
Yeah.
They have questionable values, including elected people have questionable values. And I think all the list of the things, except for superintelligence, applies to humans. And no one is scared of unmatched wisdom at this point, I think. So I'm wondering why some countries have a minister of artificial intelligence and
Just
no
one.
country. Yeah, one. Everyone is freaking out about artificial intelligence and those subjects. And why is no one having those discussions and a minister of biological intelligence, which today is making all the decisions? And follow-up question isn't the fact that we are scrutinizing artificial intelligence, doesn't it make it obviously better than human intelligence? Just because we are looking at those concerns now, we should have had that for human intelligence hundreds of years ago.
Yeah, well, I mean, in some sense, as I said, in some sense, the systems that we put in place as a society with various means, various law, systems in various parts of the world, they are intended to address these concerns for human beings, like some laws, no? Like, for example, it is not legal to discriminate when you hire somebody on gender, on whatever, age, or so there are laws, but all these laws, they take into account the fact that it's a human being issues, right? So now that we are going to work more and more with machines, some of this, so you need to have the same concerns also about machines, okay? Because machines are going to make decisions, make recommendations. So just like you had concerns and you decided about regulations to the concerns with human beings, you also now do the same with machines. Also because even if machines are not going to be autonomously making decisions, but are going to work with human beings, if I am a doctor and the machine, I don't even know whether it's biased or not, or whether it gives me random suggestions or not, I mean, I need to understand why is it telling me something? What values does it have? Does it know that I have my Hippocratic oath to follow? And does it follow that as well? So if we don't scrutinize these machines even more than we scrutinize human beings, then the human beings are not going to adopt whatever good decisions the machines may make. So in some sense, when you want to build a team between the machine and the human being, you need to scrutinize more, because when there is a team between two people, I can, maybe I have never met you before, but I know that we share a lot. We share, for example, the same experience of the world, the same kind of common sense reasoning. Maybe we don't share the values. Maybe, some values we don't share. But I know that there are many things that we share. The same kind of education, the same, not the same knowledge, but the same environment where we listen to things and so on. So with the machine, I don't have that. The machine can be completely, come from Mars, somebody from Mars, and I need to scrutinize it more than I need to scrutinize a new team member. Of course, when a team member is new, you ask more questions probably than at the beginning than later on, and the same maybe will be with the machine, but the machine even more, because you don't know what to share or what you don't share with the machine. So I understand it is true that the bar for scrutinizing the machines is higher than for human beings. Yeah. Yes.
Come on. Given the differences that exist geographically, politically, socially, and economically between many of the major players within the AI space, what are your thoughts on whether we'll be able to reach some sort of global consensus in terms of deployment and utilization of AI? And who do you think would enforce something like that? Would it be the UN or some sort of other NGO?
Well, there are many worldwide initiatives. For example, there is an initiative that started by Canada and France to build an international panel on AI, similar to the International Panel on Climate Change, which is worldwide, but similar, but not really similar because the issues are different and the fundamental, scenario is different. But the idea to build something worldwide that can discuss and be factual about the capabilities of these technologies and their risks. That doesn't mean that there will be solutions that are applicable, the same solution everywhere in the world. I mean, we know that different parts of the world have different priorities over the values. Like in some parts of the world, individual privacy is much more important than stability of the collectivity. In other parts of the world, it's completely the opposite because it's very easy to judge as very negatively what happens in China with AI, but my colleagues in China, they say, well, for us, individual privacy is not the most priority, the highest priority value. Societal cohesion and harmony is more important. So for them, although they see this attempt, to regulate and to surveil and so on, but they don't see it as clear cut as I was to say, oh my God, they're surveilling everybody, they're having this social score and so on. So we know that different parts of the world have different priorities over the values, so probably the same exact solution will not be overall, but it's important that they all talk and discuss and factually they understand the same thing because just like, in the climate change, but possibly even more successfully than the climate change part. Yes?
Hi. Personally, I'm ambivalent about self-driving cars, and particularly given the example you used, I'm very interested to hear your take on the future and the accountability of it.
Yeah, well, for me, self-driving cars, really self-driving cars, level 5, of the autonomy, are going to be deployed very, very far in the future. Okay, but in the meantime, all the work on self-driving cars is advancing AI, many kinds of AI, because self-driving car is really needs a lot of different kinds of AI. It needs to look at the pedestrian, needs to understand the videos, images, anticipate and predict what people will do. So it needs a lot of advancement of AI. So in all these technologies are going to be used in many other things, maybe not self-driving car, and they're going to be used more and more in assisting our human driver. And they are already used like that, like to keep the lane, to see an obstacle that you didn't see at the last moment, and so on, to keep the distance with the next car, and so on. So more and more already, the overall goal, which is one of the goals of self-driving cars, which is to save a lot of lives, is achieved by assisting us, in helping us when we are distracted, when we fall asleep, whatever. So in some sense, we will see. I think that we will see a lot more of this in cars. That maybe they're not just the high-end cars, but every car. And this is already, will achieve a lot. And then. The real full autonomy, another difficulty besides the legal accountability and so on, another difficulty is the fact that when we drive, we use a lot of visual communication with other drivers, like at the stop sign, for example. And so we need to understand how to do that with self-driving cars. If self-driving cars are going to be in the streets together with human-driven cars. And that transition is going to be difficult, much more than a situation where there are only self-driving cars. And then they can communicate with each other in other ways which are not visual, and maybe they can, regulate each other in the traffic and so on because of their ways of communicating and interacting. So to me, the level 5 autonomous self-driving cars are very far, but it doesn't mean that many of the goals of self-driving cars cannot be reached and even in the way to go in there.
One last one.
Yeah.
I was wondering, when you spoke about these sort of coalitions and panels to think about and discuss AI, and I just wonder how relevant these things will be, because it seems like from what I see from the media, it seems like society is so money driven, and the ethics now are so much like, if it's legal, I can do it. I just wonder what relevance will these panels have? And also, would you be able to provide some example or examples of a company which voluntarily said, we won't do this AI related thing because we feel it doesn't correspond with our values or it's not ethical?
Yeah, so about the relevance of these initiatives, well, I mean, some of them are very visible. Some of them, like the one put together by the European Commission, I think is going to be relevant with the new now there is a new European Commission that has been voted in the summer, but so the idea is that they are going to take some of our recommendations, the recommendation of the high-level expert group on AI, to really make sure. And in Europe is the kind of place that this, of course, can happen easily, because compared to US, Europe is more regulatory based, no? Rather than bottom-up innovation, and then we'll see if things go wrong and on, which are here, which has pros and cons, of course. And so I think that initiative is going to be relevant for the way Europe is going to deploy, develop, and use AI. The Partnership on AI is a visible organization. It had several hearings with the policymakers in Washington, so it is being visible. And for example, one report that the Partnership on AI recently published about 10 recommendations and 10 risks and concerns for using AI in the US judicial system for assessing risk of recidivism, like the Compass algorithm and so on. So that report has been very, very scrutinized and received and read and discussed by policymakers as well. Then in terms of companies, well, you know of many companies. I mean, at IBM, the whole AI trust initiative injects some explainability and bias detection mechanism into even the platform that we develop and we deliver to our clients. And of course, this takes time, which you cannot deploy something else. So in some sense, resources are devoted, or you can see other companies like Google and Facebook. I think Google, you can see, what they had some use of technology that was not considered acceptable by some people in the company, and the company changed its mind. So more and more companies in general, I think that they understand it's not just that to protect the brand of the company, which means money. If you just think that this is the only thing that company cares, which I don't think, but even if you think that money is the only thing that company cares about, to protect their business model and their brand, they understand that following and being compliant to the law is not enough. Because if your client loses trust in you, then it's very difficult to regain that trust, and you're going to lose your business value just because, even if you were compliant to the law. So that thing is something that companies more and more are aware of, and their clients are telling them, look, how are you going to, you give me this thing, but did you check for bias? Because I heard that, that bias can, put me into trouble. So did you check for that? What kind of bias do you have that? So more and more people understand in companies that the AI ethics, which is beyond being compliant to the law, is useful for protecting the company. So being compliant to the law is not enough, because if you lose trust, then it's very difficult to regain it, especially in an environment where there are many competitors. There are many cases in which there are no competitors, like social media. Where do you? Well, okay, some people went out of Facebook, but where do you go? If you like Facebook, you use Facebook. You connect with others. You do many things. You keep track of many. But if you don't want to use IBM, there are other companies that can do similar services to you as a company. So it's very important in a competitive environment that you cannot lose trust, because trust is a competitive advantage. If you are trusted and there are other companies not trusted. So if you lose it, then it's really very damaging for the company.
Well, we all learned a lot. We've given us a lot to think about and work towards. So thank you so much. And once again,
thank you.
A hand for Professor Rossi.
Thank you.